we want to look at some other rules for finding derivatives. One rule is the derivative sum rule. And the derivative sum rule tells us that if we have the sum of differentiable functions, then we can find their derivative by taking the derivative of each of the differentiable functions. For example, if we have the derivative of x cubed plus 4x squared minus 5x plus 1, we will find this derivative by taking the derivative of x cubed plus the derivative of 4/3 x squared minus the derivative of 5x plus the derivative of 1. Now we do not want to write this notation out every time, but just so that you'll understand what we're doing, we will go through and take the derivative of each term when we have a sum or difference. The derivative of x cubed is the power rule. We make the 3 a coefficient, subtract 1 from the exponent, and we'll have 3x squared. Plus, 4/3 x squared is also a power rule. 4/3 is a constant multiple, so that's 4/3 times. Bring the 2 out to the front to be a coefficient. Subtract 1 from your exponent, you have x to the first power, minus. Now when we have a term of the form ax, remember 5 is a constant multiple, and when we find the derivative of x, then 1 is our exponent, so it becomes our coefficient. If we subtract 1 from 1, we'll have x to the 0. Now remember that any non-zero number to the 0 power is 1. So the derivative of 5x is going to be just 5. And any ax term will work similarly. The derivative of 1 is 0, since 1 is a constant. So that leaves us with 3x squared. 4/3 times 2 is 8/3, so plus 8/3 x, and 5 times 1 times 1 is 5. So the derivative of x cubed plus 4x squared minus 5x plus 1 is 3x squared plus 8/3 x minus 5. Now we're going to use this rule and apply it in a problem. This question is, where are the horizontal tangents of y equals x to the 4th minus 2x squared plus 2? Now remember that horizontal tangents are tangents that have a slope of 0, because horizontal lines have a slope of 0. And the slope of our tangent lines we can find by taking the derivative. Now we have y, so we're going to call our derivative y prime. We use the sum rule. Since we have the sum or difference of 3 terms, we're going to go through and take the derivative of each. The derivative of x to the 4th will be 4 x to the 3rd minus the derivative of 2x squared will be 2 times 2 is 4 x to the first power, and the derivative of 2 is 0. So our derivative of y is 4x cubed minus 4x. Well, if we're looking for horizontal tangents, we want to know where 4x cubed minus 4x is equal to 0. So in order to solve this, we will factor, and first thing we will do is take out a common factor, which is 4x, and we'll have 4x times x squared is 4x cubed. 4x times negative 1 is negative 4x. Then we'll factor x squared minus 1. This is a difference of squares. X times x is x squared. 1 times 1 is 1. 1's a plus, and 1's a minus. And we're looking for where this is equal to 0. Well, remember, if 3 things multiply together to give us 0, then one of those 3 must be 0. Either 4x is 0, or x plus 1 is 0, or x minus 1 is 0. I can divide both sides by 4, and my first answer is 0. Subtract 1 from both sides, and my second answer is negative 1. And add 1 to both sides, and my last answer is positive 1. And you can see from the picture here, that is where our graph has horizontal tangents. It is at the point negative 1, 1, at the point 0, 2, and at the point 1, 1. Another rule we use often is the derivative product rule. What the derivative product rule tells us is that the derivative of a product is the first function times the derivative of the second, plus the second function times the derivative of the first. Now, in a case like the example I have here, we could multiply our two binomials together and use the sum rule. However, we cannot always multiply and simplify our products, so we're going to have to apply this product rule in certain cases. The way the product rule works is we take the first function, which is x squared plus 1, times the derivative of the second, which is x cubed plus 3, plus we take the second function, which is x cubed plus 3, and we multiply by the derivative of the first function, which is x squared plus 1. So I have x squared plus 1 times. The derivative of x cubed is a power rule, so that is going to be 3x squared. And the derivative of 3 is 0, so we have just 3x squared. Plus x cubed plus 3 was our second function, times the derivative of the first. X squared is a power rule, so that's 2x. The derivative of 1 is 0, so our derivative of x squared plus 1 is just 2x. Now distribute. X squared times 3x squared is 3x to the fourth. 1 times 3x squared is 3x squared. X to the third times 2x is 2x to the fourth. And 3 times 2x is 6x. Now collect your like terms. 3x to the fourth plus 2x to the fourth is 5x to the fourth, plus 3x squared plus 6x. Anytime that we have a product and we want to take the derivative, if we do not actually multiply and simplify, we have to use the product rule. Now the last rule we want to look at is the derivative quotient rule. In order to find the derivative of a quotient, we take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and we divide that by the denominator squared. Now of course v of x cannot be 0, otherwise that would make this fraction undefined. Now a mnemonic device I've heard for this is low d high minus high d low. Down below the square will go. Low d high minus high d low. Down below the square will go. So if we apply that, low is the denominator, x squared plus 1. D high, that's the derivative of the numerator, which is x squared minus 1. Low d high minus high, which is the numerator. D low is the derivative of the denominator. And down below the square will go. So this is all over x squared plus 1 squared. So we have x squared plus 1 times the derivative of x squared minus 1. Well, the derivative of x squared is 2x, and the derivative of 1 is 0, minus x squared minus 1 times the derivative of x squared plus 1. Well, that derivative will also be 2x, and the derivative of 1, of course, is 0. And this is all over the denominator squared. Now use your distributive property. X squared times 2x is 2x to the third. 1 times 2x is 2x. Now be careful here because of the minus. You need to make sure that you're distributing the minus and the 2x. So it's negative 2x times x squared is negative 2x to the third. And then I have negative 2x times negative 1 is positive 2x. And that's all over x squared plus 1 squared. Well, on top, our 2x cubes will cancel, and we have 2x plus 2x is 4x, divided by x squared plus 1 squared. So the derivative of x squared minus 1 divided by x squared plus 1 is 4x divided by x squared plus 1 squared. Now, as we apply our derivative rules, we can find more than just the first derivative. And so we're going to take this example, and we want to find the first 4 derivatives. Now, since we're using the notation y equals, we'll call our first derivative y prime. Y prime is the derivative of y with respect to x. So we will find the derivative of y, and that is, of course, a sum rule. We'll do the power rule on the first, 3x squared minus bring our 2 out, and we already have a 3, so 2 times 3 is 6, so minus 6x, and the derivative of 2 is 0. So the first derivative of y is 3x squared minus 6x. Now if we find further derivatives, like the second derivative, that means we're finding the derivative of the first derivative. So we take 3x squared, we bring the 2 out to the front, 2 times 3 is 6x, and the derivative of negative 6x is negative 6. So that's the second derivative. The second derivative is the derivative of the first derivative. Now we can keep going with this. The third derivative will have 3 little marks, and that's the derivative of the second derivative. The derivative of 6x is 6. The derivative of negative 6, of course, is 0. Now notice how I put 1 mark, 2 marks, 3 marks. When we get to the fourth and higher derivatives, we will put a little exponent with parentheses around it. This means the fourth derivative. Of course, the derivative of 6 is 0. We could go on similarly with this and just put a 5 or a 6 or a 7. Of course, the derivative of 0 is going to continue to be 0, so every derivative from this point forward would be 0.